Your phone can do over 10 trillion calculations per second. The average American household has over 20 connected devices, whether it be a laptop, a phone, a smart fridge, or even a microwave. You've probably interacted with a computer today. As somebody going into electrical engineering, I've done a lot of research on how computers work at a fundamental level. Today I'll be explaining how computers do basic calculations. I'll start by explaining the bit. I'll then move on to talking about how bits store numbers. And then finally, I will talk about how numbers are added together on computers. First, the bit. The bit is a binary value, meaning that it is either a 0 or 1. According to a video from Khan Academy, the bit is the most fundamental building block of computer data, meaning that it stores anything from text to the video calls that you have. The transistor is a physical component on your computer which processes bits. According to the National Institute of Standards and Technology, the bit is stored by a capacitor, which is charged with a transistor. If a capacitor is storing charge, it is storing a 1, otherwise it's storing a 0. Bits store in chunks of 8 bits called bytes. These bytes, as represented here by the letter A, can represent much more complex data than just 1s and 0s. Now that you know a bit more about bits, I'll move on to explaining how numbers are stored by 1s and 0s. In binary, they only use 1s and 0s, not any of the numbers 2 through 9. This means that you can only store information in powers of 2, as explained by Marshall Brain on how stuff works. In this example, we are representing the number 10 as 1010. We're representing it this way as it is 18, 04s, 12, and 01s. Computers also have to store negatives and decimals if it wants to do all of the calculations that humans can. To start with negatives, computers store negatives using something called sign magnitude. This means that the first bit in the computer's storage tells you whether the number is negative or positive. Following that up is decimals. Computers store decimals using a system similar to scientific notation. Every time you move over a digit past the point, you are dividing the number by 2. This means that this number, 0.11, is equal to 0.5 plus 0.25, or 0.75. Now that you know how numbers are stored on computers, I will move on to talking about how adding is accomplished on computers. All calculations are based on addition on a computer, and this addition is done by logic gates. Logic gates are used to compare bits. The most notable example of this in addition is the XOR gate, which outputs a 1 only if one of the 2 bits inputted is a 1. By linking multiple gates together, you can build something like this, which is an adder. This is a table describing how an adder takes input in and outputs based off of that. A 0 and a 0 would output as 0. If either of the bits is 1, then it would output as 0, 1. And then if both bits are 1, it would output as 1, 0, which is equal to 2. Omar Muñez Urias explains on Build Electronic Circuits that by combining many of these adders together, you can add as large numbers as possible as you wish on computers. From the bit to addition, computers use simple building blocks to build the huge world online. I explained how the bit works, how they store numbers, and how these numbers are added together. I hope next time you look at your computer, you think about all the calculations that are going on, bit by bit.